Hey guys, welcome back. We have completed the topic regarding redox definitions of oxidation and reduction separately, along with the different examples of both of the reactions. Here, right now, we are going to start the topic that is oxidizing agents and reducing agents. What are oxidizing agents? What are reducing agents? How they are behaving, etc. Before moving ahead, I would like to bring your attention to the point that oxidizing agents are also called as oxidants. Okay, done. And reducing agents are also called as reductants. So these are the second names for these two. Right now, I'm changing the page and I am taking you to a list of oxidizing agents and reducing agents. Before moving towards the list, you people should know what is an oxidizing agent. Okay. Oxidizing agent is a substance, is a reagent, is a chemical, you may say, is a reagent which oxidizes others. If it is oxidizing others, it means getting itself reduced. Okay. So itself undergo reduction. Done. Okay. Then what about the reducing agent? Definitely, reducing agent is reducing others. Reducing agent is reducing others. And we can say this thing that itself, oxidizing, oxidizing itself. Okay, how it is happening? Look at the next page. Guys, just consider the example of sodium chloride formation. I am giving you this example frequently. Why it is so? Because this is a very common example. Many of the students have already a very clear ideas about sodium chloride formation. From this simple example, you can understand other complicated examples little while after some interval of time. Okay, look at this example. This is a balanced chemical equation. We are saying this thing that sodium is changing itself into sodium ion, whereas chlorine is changing itself into chlorine ion, or you may say chloride ion. Okay, now sodium atom is losing one electron and turning itself into Na plus 1. Okay, that is sodium ion. In the same way, chlorine atom is gaining one electron and turning itself into chloride ion. Okay, now we can say that sodium is undergoing oxidation as sodium has lost an electron. Where that electron is going, then this electron is gifted to chlorine. Chlorine has received that electron. We can say this thing that sodium has given its electron to chlorine. So sodium has undergone oxidation itself, but it has made chlorine to get reduced. So as a result, sodium is acting as a reducing agent. Now we can discuss about chlorine as well. Chlorine is receiving that electron from sodium, so we can say that chlorine is undergoing reduction as it is gaining an electron. But when chlorine is making sodium to give that electron, it means that chlorine is making sodium to be oxidized. So we can say that saying that sodium is undergoing what? Undergoing oxidation. Okay, and reducing chlorine. Reducing chlorine, behaving as what? Reducing agent. Behaving as reducing agent. So guys, in short, the ones which are undergoing oxidation, behaving as reducing agents, and the ones which are undergoing reduction, behaving as an oxidizing agent. So this is the total story which I have just summed up. Okay, so this is I have written for chlorine. Now I can tell you for chlorine as well. Okay, after sodium, I can write for chlorine. For chlorine, what we say, undergoing what? Undergoing reduction, undergoing reduction. And then what is the next one? The next one is behaving as what? Behaving as an oxidizing agent. Behaving as an oxidizing agent. Okay, so this is the total story related to oxidizing agents and reducing agents. We will discuss certain other examples from the past papers as well, but not at this stage. Let me finish this chapter and I will discuss some papers with you, inshallah. Let me go to the next page so that I may tell you a list of oxidizing agents and reducing agents. Fortunately or unfortunately, guys, you people have to memorize that list. It will be my advice to all of you to memorize that list. If you will memorize that list and keep that list in your mind, it will help you to solve many of the questions. Okay, so here there is a list for oxidizing agent and here there is a list for reducing agents. Okay, in case of oxidizing agents, the number one is K2Cr2O7, that is called as potassium dichromate. Okay, next one is KMNO4, that is called as potassium manganate, or it is called as potassium permanganate as well. Okay, commonly called potassium manganate. Next is all non-metals. All non-metals are acting as an oxidizing agent. Okay, then we have an example of O2 as well. Then we can have an example of H2O2 as well, which is called as hydrogen peroxide. I'm making a star with it. And there is another example, that is all acids are behaving as an oxidizing agent. If we are talking about reducing agents, we can say it is potassium iodide, that is a reducing agent. We can say all metals are what? All metals are reducing agents as well. H2S called hydrogen sulfide, sulfur dioxide, SO2, ammonia, NH3, hydrogen gas as well. And there are some other examples, that is FeCl2, iron chloride, or it is called as iron 2 chloride. I mean to say, we are writing this as iron bracket 2 chloride. What is this 2 thingy? This 2 is saying that iron has a charge of +2. Iron has an oxidation state of +2 here. There is another, and that is called as FeSO4. This is also called as iron 2 sulfate. Iron 2 sulfate means iron has an oxidation state of 2, just like iron 2 chloride. And we have written this, all acids are oxidizing agents. There is one ki which I have written at the top. Remember this thing, that H2O2 will be written here as well with a star. Why this is with a star and why it is written in both columns, we are going to discuss it shortly, inshallah. And there is an other which are called as alcohols. List of reducing agents is longer as compared to oxidizing agents. Guys, there are only three out of these two, total two lists, of which color changes should be in your mind. And what are those? This is potassium dichromate, KMNO4, and the one is Ki. Okay, only these three are there in these two lists, of which color changes should be in your mind. And what are the color changes, that I am going to tell you shortly. What is the meaning of the color change? Meaning of the color change is that oxidizing agents are reacting with reducing agents and there is a color change. Reducing agents are reacting with an oxidizing agent and there is a color change. Guys, I would like to inform you that if an oxidizing agent is reacting with an oxidizing agent, no reaction will happen. Okay, no reaction will occur. No reaction will occur. Okay, no reaction will occur means no change will be observed as well. Okay, no change will be observed. Okay, so when there will be a change, when a reducing agent is reacting with an oxidizing agent, then we can say that a color change is observed. Color change will be seen. Okay, now what will be the color change, and that I'm going to discuss with you here. One of the color change is about KMNO4, that is called as potassium manganate. Guys, I'm writing the formula again and again, and I'm telling you that many of the students are writing wrong formulas. Sometimes I'm watching some such type of formulas as well. or KMNO4, something like that, which is the wrong thing. And then sometimes I'm observing this type of formula. This is capital, suddenly this N is capital, and something here, which is wrong. All these formulas are wrong. Please make sure that all these formulas are giving a very bad impression of a student on examiner. So please be aware of the right formulas and try to make the practice of writing right formula. Okay. So what I'm saying about KMNO4, it is an oxidizing agent, and when it is reacting with a reducing agent, when it is added to a reducing agent, there is a color change. Okay, color change is happening. Okay, what I'm saying, that KMNO4 is an oxidizing agent. When it is added to a reducing agent, there is a color change. And what is the color change? The color change is from purple to colorless. Okay, now there is a point, purple to colorless. Okay, now there is a point, and what is that? That you have to mention the color change. What is the meaning of a color change? You have to tell the starting color, you have to tell the ending color, you have to tell it that what is the color before reaction and what is the color after reaction. Okay, so this is the point. You should know this thing, that color change means you have to tell the whole story before and after. Okay, so what is the color of KMNO4? Purple. Original color of KMNO4 is purple. And what is the color of KMNO4 after reaction? That is colorless. Is that okay? So this is how we are going to implement the color changes of KMNO4. I am on the next page, and here I am discussing the color changes about K2Cr2O7. Again, guys, this is an oxidizing agent, and when it will be added to a reducing agent, there will be a color change. Okay. One thing I would like to tell you before moving ahead, that if KMNO4, which I have just discussed with you on the previous page, it is an oxidizing agent, and when it will be added to another oxidizing agent, no color change will be seen. So for example, examiner is saying that X is added to KMNO4, and there is no color change, purple stays purple. Okay, no color change. Then what will be the nature of the X must be an oxidizing agent, because being an oxidizing agent, it is not reacting with KMNO4, which is also an oxidizing agent, hence no color change is seen here. Okay, so back to the story of K2Cr2O7. What is the K2Cr2O7 original color? When it will be added to reducing agent before reaction, its color is orange. Yes, I have selected an orange color. Yes. And after the color change, after the reaction, what is the color change? It is green. Oh, I'm writing with the green color now. Yes. So, guys, I would like to inform you that what is the original color of K2Cr2O7? It is orange in color. And what is the final color after reaction with the reducing agent? It will be green. And for example, examiner is saying that A is a substance. It is added to K2Cr2O7, and no color change is seen. Okay, no color change is seen. From the idea of KMNO4, you should know this answer. No color change is seen. Okay, then what we can say, what will be the nature of A? We can say this thing, that A will be an oxidizing agent. Why? Being an oxidizing agent, it is not changing the color of K2Cr2O7, which is also an oxidizing agent. Okay, then we can change it to the next page, and that is about Ki. Guys, what is Ki in the list of the oxidizing agents and the reducing agents? You now know this thing perfectly, that Ki is a reducing agent. Okay, so we can say this thing, that Ki, being a reducing agent, will change its color in the presence of an oxidizing agent only. Reducing agent Ki is not changing its color in the presence of another reducing agent. So here we can say that what is the nature of Ki? That is potassium iodide. Okay, and it is a reducing agent. When it will be added to an oxidizing agent, the color change is from colorless to brown. Okay, so we can say this thing, that Ki is undergoing a color change, that is from colorless to brown. And when it is happening, if an oxidizing agent will be added to Ki, then this color change will be observed. Okay, So, guys, there is one very interesting question by examiner, and what is that interesting question? Let's discuss. For example, examiner is saying that Ki is added to KMNO4. Okay, what will be the color change? Okay, so the answer is from purple to brown. Okay, why it is so? Guys, what is the starting color of Ki? What is the initial color of Ki? It is colorless. Okay. And what is the ending color of Ki? It is brown as well. Okay. Now, what is the starting color of KMNO4? It is purple. And what is the ending color? It is colorless. Okay. Guys, I don't have a colorless color to write on the board. Okay. So it is colorless. Okay. Now, for example, if we are saying that these two colors are mixed up with each other, that is that is purple and colorless colors are mixed up with each other, what will be the color? It will be purple. So when Ki will be added to KMNO4, colorless is added to purple, what color will be seen at the start? It will be purple. Okay. And what will be the ending color? It is, now we are saying that, okay, I'm changing it and I'm taking the blue color. Okay. When brown will be added to colorless, brown and colorless are there. Okay, so what will be the color seen? It will be brown. So initial color of the mixture of Ki and KMNO4 will be purple, and the final color of Ki and KMNO4 will be brown. So this is how we are investigating the colors. This is one of the past paper question which examiner has asked this thing. Might be some of you champions might be thinking like this, that what will be the color change if K2Cr2O7 is mixed up with Ki? Guys, in that case, actually, there is no colorless situation in case of K2Cr2O7, not at the starting point, not at the ending point. That's why question related to K2Cr2O7 cannot be asked. This is the reason behind that. Okay, so please don't get upset about that. That if examiner will ask a color change regarding Ki and K2Cr2O7 mixture, what will be our answer? Examiner will not ask such type of a question in which from one person to another person, color perception can be different. So in that case, in case of K2Cr2O7, as there is no colorless situation, neither in the start nor at the end, that's why examiner is not going to ask such type of a question from you. So these are the oxidizing agents and reducing agents, about which I have just told you, that oxidizing agents are the oxidants which are making others to get under oxidation. And what about the reducing agents? They are behaving as reductants. They are acting as reducing agents. They are causing others to get under reduction. Okay, so this is how oxidation and reduction processes are happening, and these are the color changes associated with them as well. Okay, and these color changes of only these three should be in your mind, as these are the part of your syllabus. Okay, before moving ahead, I would like to bring your attention to the next point, and that is about H2O2. Guys, in case of H2O2, that is called as hydrogen peroxide. Okay, hydrogen peroxide. Guys, can you look at there that there is an equal ratio of hydrogen and oxygen in this compound, 1:1. Okay, gain of hydrogen is called as reduction, whereas gain of oxygen is called as oxidation. So that's why, as the ratio of oxidizing agents and reducing agents, as the ratio of hydrogen and oxygen is being equal in hydrogen peroxide, that's why in the presence of an oxidizing agent, it is behaving as a reducing agent, and in the presence of a reducing agent, it is behaving as an oxidizing agent. So we can say this thing, that hydrogen peroxide has a dual type of a nature. Okay, has a dual type of a nature. We can say this thing, that if hydrogen peroxide will be added to KMNO4, there will be a color change, and that will be from purple to colorless in case of KMNO4. From purple to colorless, we can say this thing, that hydrogen peroxide will decolorize KMNO4. Original color of KMNO4 is purple. If we will take the bottle of KMNO4 right now in front of us, it will be of purple color. But when hydrogen peroxide is going to react with this KMNO4, it will make that purple into colorless. Okay, then if we have added hydrogen peroxide into Ki, we can say this thing that original color is colorless and after color will be brown. Okay, so we can say this thing that these are the color changes associated with Ki and these are the color changes associated with KMNO4 if hydrogen peroxide is added. So these two color changes are giving us an evidence to recognize the nature of hydrogen peroxide, that it has a dual type of a nature. And what is the reason behind that? That I have just told it to you, that as it has an equal proportion of hydrogen and oxygen, that's why it is behaving dually. Okay, so this is the reason behind that. So we have discussed about oxidizing and reducing agents in detail. Guys, I would like to bring your attention to the next point of this chapter after completing the definitions of oxidation and reduction, and after the completion of oxidizing agents and reducing agents and their color changes as well. There is one point which is called as oxidation state. Okay, and that is called as oxidation state calculation. Okay, now oxidation state is what? Okay, so it is actually the charge, it is actually the charge on an atom of an element. Okay, basically it is a charge on an atom, basically. Okay, and that is called as oxidation state. Oxidation state is a variable thingy, is a variable state in some types of the compound, where in some types of the elements, but in some types of the elements it remains same. What is the oxidation state of different types of the elements? There are certain rules which I am going to tell you, and how to calculate oxidation state, it is really an important thing to understand at this level as well, and it will be helpful to you regarding the topic of redox, which we will teach you in AS chemistry. Okay, so right now oxidation state has certain rules, and what is the rule number one? Oxidation state of a free element, free element is zero. Okay, now the point is that what is a free element? A free element is an uncombined element. It is an element in its natural state, which is not part of any compound. We can say this thing an free element or an uncombined element. Its oxidation state will be zero. Its charge will be zero. So just consider one atom of carbon. It is not part of any compound. We will say its oxidation state is zero. Just consider sodium metal. It is pure sodium metal. It is not part of any compound. We can say its oxidation state is zero. So this is how we can say that what is the oxidation state of an atom, of an element, in its free state, in its uncombined state. Okay, number 2 point is oxidation state of a total compound, of a total compound is zero. How it is? Now the point is that oxidation state of a total compound. So complete compound NaCl, what is the oxidation state? Zero. Complete compound K2Cr2O7, what is the oxidation state? Zero. Total compound KMNO4, what is the oxidation state? Zero. So what is the oxidation state of KMNO4 in total? Is equal to zero. The total KMNO4 has an oxidation state of zero. Okay, so positive and negative partners are combining in such a ratio that they are cancelling each other's charge, and as a result the final charge on the compound is zero. Okay, this is the basic thing which you people should know, that positive and negative partners are combining in such a ratio that they are cancelling each other's effect, and the final compound is zero. Is that okay? So this is how we are calculating the oxidation state of the total compound. Now, next rule is on the next page, and what is that? That is number 3. Okay, oxidation state of group number 1 elements is +1. Elements of group number 1: lithium, sodium, potassium, rubidium, cesium, francium. All these elements have an oxidation state of +1. When it is +1, when they are part of any compound, we are going to consider it as +1. So for example, let's consider Ki. It has an element of group number 1. What is that element? It is potassium. So its oxidation state will be considered as +1. But if we are considering potassium alone, a potassium atom which is not part of any compound, we are considering it alone. What will be the oxidation state of potassium then? It will be considered as 0 at that stage. Why it is so? Because it is not part of any compound. Here we are going to consider it as 0. Okay, but when potassium is part of a compound, then we are going to consider as +1. Okay, then we have an oxidation state of group number 2 elements. It will be considered as +2. Same story as that of potassium. What are the elements of group number 2? Beryllium, symbol Be. Okay, beryllium, magnesium, calcium, strontium, barium, radium are the elements of group number 2. Basically, we are not discussing mostly about radium and francium. I have discussed this thing in some previous lectures as well, that these both francium and barium are these both francium and radium are the radioactive elements. Radioactive elements are emitting radiations out of them. As a result of them, they will not remain in the same state. That's why we are not discussing them mostly. But if we have to discuss it, then we can say that being an element of group number 2, it has an oxidation state of +2. Okay, so oxidation state of all the elements of group number 3 have group number 3 is +3. So this is how we are calculating the oxidation states of different elements of group number 1, 2 and 3. If we are talking about the oxidation state of oxygen, okay, yes, oxidation state of oxygen will be considered as -2 as far as it is in peroxide. If oxygen is in peroxide, where is the example of peroxide? Is there any example of peroxide? For example, hydrogen peroxide. Okay, this is a very common example of peroxide. Peroxides, peroxides. Okay, so here it will be considered as -1. Otherwise, oxygen's oxidation state is -2. There is one other compounds which are called as superoxides, but they are not part of your syllabus. That's why I'm not mentioning them. Okay, so there is an other that is number 4. That is number 4, not number 5 here. Okay, number 5, and that is oxidation state of hydrogen. Oxidation state of hydrogen is +1. As far as oxidation state of other elements is to be discussed, then we can tell about regarding their group numbers. Hydrogen is at the top of the periodic table. We are discussing it very specifically. Oxidation state of hydrogen is +1. Otherwise, if it is part of metal hydride, what are metal hydride? When metals are in combination with hydrogen, then those compounds are called as metal hydrides. Here the oxidation state of hydrogen is -1. Yes, please be careful about that. If a metal is attached with hydrogen, metal will be having a positive charge, whereas hydrogen will have a -1 charge. Okay, so this is one of the things which you people should know in your mind, should keep in your mind. If we are talking about the oxidation state of an ion, oxidation state of an ion, then we can say this thing, that oxidation state of an ion is equal to its charge, is equal to its charge. What is the example for this? So consider the ion Na+1. It is an ion. It has a charge of +1. So its oxidation state will be +1. Consider another ion, that is O2 minus. It is an ion which is about oxygen. And what will be the charge on that? It will be -2. So we can say this thing, that oxidation state of sodium is +1 and oxidation state of oxide ion is -2. Why it is so? These are the charges on these ions and these are the oxidation states associated with these ions. Okay, now I am on the next page and I am talking about the oxidation state of a radical. Okay, number 7, oxidation state of a radical. What was a radical? Radical is also called as polyatomic ion. Every time I am telling you about all this story, polyatomic ion. Okay, what about the oxidation state of a radical or a polyatomic ion? Is equal to its charge. Okay, is equal to its charge. Guys, I would like to inform you that in case of a radical or a polyatomic ion, how the oxidation state is becoming equal to their charges. For example, let's consider sulfate. It has a formula SO4 2 minus, so its oxidation state will be equal to 2 minus. Let's consider another OH 1 minus, so its oxidation state will be 1 minus. Okay, let's consider one with the positive sign, that is ammonium, and its oxidation state will be plus 1. So by implementing, by utilizing these rules, we can calculate the oxidation state of a specific certain element in a compound or in a radical as well. Let's have a practice about that right now. Okay, so for example, let's consider it is K2Cr2O7 called potassium dichromate. What is the oxidation state of chromium? Examiner will ask about the oxidation state of a specific element. So please, sometimes students are asking me how we know this thing about which we are calculating right now. Examiner will ask this thing, examiner will mention this thing. Sometimes we have to implement this story of oxidation state while solving some of the MCQs. For example, examiner can ask this type of a question: which of the following is undergoing oxidation, which of the following is undergoing reduction? So in that case, you can calculate the oxidation state. By making a little bit practice, it will become very convenient for you to understand that which element is undergoing oxidation or vice versa. Okay, let's consider the oxidation state of chromium in this total compound. Okay, so what is the total oxidation state? It will become 0 because total oxidation state of a total compound is 0. So here potassium is a part of group number 1. It has a charge of plus 1. It is for how many times? It is for 2 times, so we are going to multiply it by 2. So that's why potassium story is over now. Okay, now the story of chromium is there, and we are writing chromium as it is. Sometimes some of the teachers are saying that we are going to write X for those elements about which we are calculating. It is perfectly right thing. But what I am observing is this: sometimes the students are writing X for the one about which they are calculating, and at the end when they are calculated, they are thinking that what we have calculated and where we have to place it. So please, you may write that element as it is. Okay, so here it is oxygen, and oxygen is minus 2. We know it is for 7 times, so we are going to write 7 as it is, and this will become 0. 7 times minus 2 is minus 14, and it is plus 2 here as a result of plus 1 times 2. Minus 14 and plus 2 difference is minus 12. That I am going to write as it is, and this is here too. It is 0 and it is 0. When this minus 12 will go on the other side of the equality, it will be plus 12. And when this CR is alone is checked, it is plus 12 divided by 2 times, because it is CR2. So it is like this, and it will become CR is plus 6. So this is how we are calculating the oxidation state of an element in a compound. I'm going to give you another example. For example, let's consider NaClO3. Okay, so it is to calculate the oxidation state of Cl in that compound, it is equal to 0. Na is plus 1 because it is an element of group number 1. It is for only one time, that's why we are not going to multiply with any number. So here we are going to write Cl as it is, and oxygen is minus 2 in the compounds except for the peroxides, which is hydrogen peroxide, a common example. It is minus 2 for oxygen, and it is for 3 times. We are going to multiply it with 3. It is becoming minus 6, and it is Cl here, and it is plus 1. And then it is minus 6 and plus 1 difference is minus 5 here, and plus Cl is like this. And when this minus 5 will go on the other side of the equality, it will become plus 5. Just imagine that chlorine can give an oxidation state of plus 5 as well. So there is a possibility that elements can violate from those rules in some of the compounds, but this is the way to calculate that. Look, we have written the oxidation state of oxygen, the one which we have mentioned in the rules, and the oxidation state of sodium, the one which we have mentioned in the rules. So we have to implement the rules to calculate the oxidation state of any unknown one. Okay, let's calculate the oxidation state of an element in a radical. Okay, so this is sulfate. and we are saying that it has a charge of -2. In that case, we are saying that we are going to calculate the oxidation state of sulfur. So we are going to take sulfur as it is, and oxygen is -2 times or -2 times 4, and then oxygen story is over. It is equal to not 0, it is equal to its charge. So that's why I have told you that oxidation state of a radical is equal to their charges. So it will be equal to -2. So it will be sulfur, and it will be -8, and it is -2. Okay. And then when this -8 will go on to the other side of the equality, it will be +8 and then -2. With the passage of time, if you will make more and more practice, after making some practice, it will not be required that you are going to write all this story. It is not required that you are going to write this whole calculation. Okay. So this +8 and -2 will become +6. So sulfur's oxidation state will be +6 here. Okay. This is how we are going to calculate the oxidation state of the elements in our radical as well. Okay. Guys, if we are going to sum up this whole chapter, I am taking you from the first page. I would like to inform you that Alhamdulillah, we have completed this chapter. Okay. So overall, there are not so many lectures for this. If I'm taking you to the first page where we have started the redox in the previous lecture, we can say this thing that in case of a redox, there are two types of the processes: oxidation and reduction. I have told you that they are opposite and parallel. We have discussed four definitions of oxidation and four definitions of reduction in the previous lecture. We have implemented it to the many definitions, many examples for oxidation and reduction as well. In this oxidation and reduction, we have discussed certain reactions regarding examples, and afterwards we have started the next topic, which is started today, and it is related to oxidizing and reducing agents. After finishing that, we have calculated the oxidation state and what are the rules of oxidation state and how to calculate it in different examples. Okay. All the best to all of you guys. Take care of yourselves. See you all with the next class about next topic.